Hello, fourth year. Something you are going to love. Pythagoras in 3 dimensions. I can hear your enthusiasm already. Actually, the good news with this, truthfully, is it, the Pythagoras theorem we're going to use is 2 dimensional. Okay, so it's not the actual mechanics of what we're going to do is the same as we've done before. It's not new maths. Okay, so that is the good news. The tricky bit, the bit you really have to think about, is trying to visualize the 3 dimensional object and then to identify where the right angle triangle is within that 3 dimensional object. Okay, so we're going to start with this example here. It's a cube, all right, you should be seeing that information there. So it tells you there quite clearly it's a cube. When you see the word cube, I sincerely hope that all of you start thinking, oh well, then every side must be 5 centimeters. So that's 5 centimeters there, and that's 5 centimeters there. So all of the sides are going to be 5 centimeters long, okay, which is great. The one thing that we can't be sure is 5 centimeters long, though, are these diagonals across these different sides here. Okay, so there's diagonals running across essentially all the squares. Yeah, so all the sides of a cube are square, so they all have diagonals running across from one corner to the other. Okay, you cannot say that they're 5 centimeters because, of course, they're not. All right, so we're asked in this question to work out the length of AC. So there's A there, and there's C there. Okay, so that is going to form a triangle. I'm going to try and draw this here, so hopefully you can see there's a sort of triangle going across there. All right, so this is easy because it's a cube. We know that one side is going to be 5, and so is the other. So let's just draw that in. Same process as I used before. I'm drawing a sketch here, right? Now, apologies, whenever I draw a diagonal line on the iPad, it goes slightly wavy. I haven't worked out why that is. I just know that it's true. So this side here is 5 centimeters, all right? Now, if I want to just copy across the letters from the diagram, this is A, okay? This is B, and this is C. Now, that corresponds exactly to the triangle that I've drawn, okay? Now that might cause a bit of complication because we are used to using b squared and c squared, sorry, a squared and b squared when we do Pythagoras theorem, okay? So we're going to have to do something just marginally different this time round, all right? Anyway, let's finish this diagram off. This was 5 centimeters here, okay? So that length AB, 5 centimeters, matches my 5 centimeters here. And BC is also 5 centimeters, and that's represented there. Okay, now I'm just going to take all that green stuff away just so you can see. All right, I'm going to label up this diagram. Now I'm just going to label that side as my hypotenuse because I know that that's a right angle in there. Has to be because it's a square. Now for Pythagoras theorem, what I'm going to do here is I'm going to write the hypotenuse squared. I'm going to call this side AB squared, okay, because I can refer to that line by its start and end point, and I'm going to refer to this one as BC squared, okay. So there's no harm in me referring to those lines by their start and end characters, okay. So AB squared plus BC squared, all right. Please don't be confused by that in terms of what we did last time. Last time what we did was give the side a single letter name. All we've done this time is give it a name based on its start and end characters, and the same with BC. We've done it with its start and end characters, so that's BC. Okay. Now, all we have to do is put in the numbers. Now we haven't, the hypotenuse is actually called AC, so let's call it that, AC squared. Can you see that? I hope. That's the hypotenuse there, AC, so we're calling it that. AC squared is equal to, now AB is 5 squared, and so is BC squared. Oops, that should be 5 squared there. So I know that 5 squared is 25, and I know that that is also 25. So we're saying that AC squared is equal to 50. So AC is going to be equal to the square root of 50. Right, now I don't know what the square root of 50 is off the top of my head. 5 root 2 as a third. But as a decimal number, that's 7.1 to one decimal place. Let's pop that in actually. Good habit. So AC is 7.1 centimeters to one decimal place. Okay. Now this next bit is really quite interesting because we're asked to work out the length of AG. Okay. So we're actually going from, I'm just going to change the color of my highlighter here just to try and make things a bit clearer. So we've been asked to go from A to G. So that's going from the front of the cube to the back of the cube. Okay, so we have to try and visualize the triangle. Now the triangle is going from the front to the back of the cube, which means that the base of the triangle is actually that line AC that we've just calculated, and the height is this line here, all right, which is GC. So this triangle is actually made up of AC and G. Okay, again, like I said before, the difficulty here is just trying to visualize the triangles. The maths is not any different to what you've been doing before. So, sketch. Oops, slight curve on that line. So this is going to be point A. This is point B. No, it isn't. Excuse me. That's actually point C. And that is point G. Okay. Now I'm just going to make C a yellow. So that's our triangle this time. Okay. Now we've just worked out the length AC, haven't we? Because that's it over there. So that becomes 7.1 centimeters there. In fact, what we might do, just to keep it nice and tidy, preserve the accuracy, is we're going to call it root 50. Okay, because that's the unrounded version of that number. So let's leave it as root 50. Okay, if you use 7.1, it's absolutely fine. Please don't worry about it. I'm just thinking about preserving accuracy here. From our diagram, we know that GC is 5 centimeters. That's that there. So let's pop that in there too. What we need to find out is AG. Okay, now AG is that magic word, the hypotenuse there. Okay, I'm just going to move this up a little bit. Right, Pythagoras theorem, write it out. Hypotenuse squared is equal to, this time it's going to be AC squared plus, let's call it CG, okay? Nothing says the letters have to be in alphabetical order, it doesn't matter. Okay, it's fine. So let's call it AC squared plus CG squared. Our hypotenuse is called AG. AC squared is root 50 squared, or 7.1 if you're using 7.1, that's also fine. Please don't worry about that. Now I know that the square root of 50 squared is just 50. And we know that 5 squared is 25. So what we're saying here is AG squared is equal to 75. And finally, AG is equal to root 75, which is 5 root 3 as a third, but not as a decimal number. So as a decimal number, that's 8.7. It's actually a rounded number, so let's just state it as that. 8.7 centimeters. That's to one decimal place. Okay. Now, that might look complicated, and I can understand why it might give you a little bit of nervousness and apprehension. It is really two-dimensional Pythagoras in a three-dimensional shape. Okay, so take your time, look at the shape, consider it carefully, construct your sketches. Please don't try and do this without a sketch. All right, it's the visualization of the 3 dimensions that people find difficult. Do your sketch, do it properly, and you should be okay. The only other difference is the way I've labelled the sides. I'm using the start and end point of the sides, 2 letters instead of one, okay? That makes absolutely no difference. The Pythagoras you're using is the same as what you did really well the other day. It's just in a slightly different context. So I'm only going to give you 3 questions, I think, in the worksheet. So there's not loads of work to do. Take your time, work through it. All right. If you're contacting me for help, the first thing I'm going to ask you is if you've drawn a sketch. And if you haven't, then do it, because I'm going to ask to see it. Okay. If there's a point in your video where you're not sure what's happening in this video, then get in touch with me. Tell me the time of the video where you stop understanding, and I'll help you with that. That's no problem. Please remember you can start and stop the video as much as you like to help you get a feel for what's going on. And this is accessible in your class notebook, okay? So you can have a look at this whenever you want to have a look at it. This page and this worked example in exactly this format is available in your class notebook, all right? Good luck with the questions. Please get in touch if you need help. Teams chat or Go email are both fine.